Hey, Rani here. Shall we make a game? So last time we started working on this kind of like engine overhaul where we're basically taking all the pieces of the game we just didn't make, but we sort of started making and started turning them into an actual engine that we can reuse between other projects. So we're going to be continuing that, really. So yeah, we made some fixes to the sort of documentation for the protocol between the WebAssembly module and its host. And we're starting to build out all of the kind of buffers and stuff that we're going to get exposed to the host. So let's go back into our assembly module. Let's build it. So let's tell it what we're building. That'd be good. Okay, so we've got a lot of errors to currently fix. Where did we get to? Okay, so use of undeclared identifier. Okay. What do you mean undefined identifier? Please explain. Oh, isn't there a thing you can do where it shows you exactly what the preprocessor output looks like? C preprocessor output clang. There we go. Yeah, that's all we need to do. Oops, don't put a breakpoint there. I don't even know what that does in this IDE. Just need to drill down to this directory, so source, engine. I bet there's a shortcut I could use to open the terminal right in this folder. And I think it's this, right? Oh yeah, this should show, yeah, now we can see exactly what's going on here. Let's copy this out into a window so we can see what's going on. Wow, this like ran War and Peace, huh? Okay. Let's grab all of this and put it here. And we can get rid of this later on, so we'll just save it for now. Let's bring in the appropriate headers so we have kind of like our primitive types. Actually, let's bring in all the headers. Is this some kind of syntax? And see, I didn't realize. Okay, so yeah, as expected, it made a 0 for basically made a 0 for each one of these and used that to kind of pre-populate the size of this and this. That worked very nicely. And then, oh, how'd that get in there? That's interesting. It didn't call that like a macro, did it? That's interesting. I thought, what? What is happening here? It looks like it only kind of went down one layer of the map. Well, actually, what? Huh? Huh? Oops. Let's just compare that to what we had in the previous project, because there could be a difference. So what we're doing here, we've got the state list and we're passing in buffer size. Okay. And we've got state list, submacro. So that looks kind of similar to me, but maybe there's a difference. Let's go back in. Let's see if we can spot what the difference is. There's going to be a difference somewhere. So buffer list. Buffer list. Let me try something. Maybe these have to be on the, they have to be on the global scope or something. I doubt it, but maybe. And let's, oh, it hasn't remembered anything I typed. Fantastic. Okay. Should have here it is, yep. Nope, it wasn't that. It is working that time though. I've got to figure out what's different between this and this. There is a difference. Oh, is there a space? Is it that space? Is it seriously that space? Is the difference between it working and not working? I think it is. I hate programming. Why do I do it? All right, okay. Now I've got that straightened out. Or maybe not. Do you want me to find out? Let's build it. Oh, that pedantic message is starting to get my nerves. Okay, that's closer. That's closer. So now we've got an IE state buffer pointers. Yep, they're no longer called that. It's just called buffer. Pointer values. There it is. Just took me a moment. Yeah, there we go. Okay, what do we have next? What do we have next? We have, where's the start of these errors? There it is. Oh, okay, this is saying that, oh, well, I'm not expecting you to cast it to another type. That's fine though, we are expecting it. We don't really care at this point, it's just pointers going out to our sort of parent, well, out to the hosting platform. Okay, that got it closer. Next up, pointer states. Next up, we need to implement the pointer buffers. So when we say pointers, we're not talking about memory pointers. We're talking about the mouse cursor. So, oh, I've already got it in here. Yeah, I do. Okay, so next up, we just need to add the rows from the top and the columns from the left. It's going to be an external, isn't it? Yep. And we're not using a float in here. Get rid of that. Maybe it should be a float. No, we'll keep it as an integer for now. Why not? Pointer row, the number of rows between the top of the, what we're going to call this? Top of the video buffer and the pointer, if known. And we're going to reference, oh, how do you do this? Is it pointer state? Like that? Is it like that? We'll find out. We'll build the documentation, see if that came through. And number of columns between the left. Yeah, let's build the documentation, see if it's happy with that. Okay, it probably didn't pull that in. Oh, it did. It did. Hey, it did work. It did work. Nice. Nice. Okay, so I might want to add these to the engine's API. Maybe. Maybe I don't. Yeah, thinking about it, this shouldn't be in the engine's API because it's not something you'd be referencing when building a game. This would. Oh, no, maybe you would. Yeah, I'll leave it like that. And go to the, what's the document called? It's called the engine API. There it is. Okay, next one is, what did I call the bit that actually does like gamepad input? Here it's protocol. Did I just call them controllers? I think I did. Yeah, I just called them controllers. So I'll add the header files for those. Okay, let's just get this sorted out. Oh, we're also going to want in the project settings, we're going to want input settings, we're going to be able to specify how many controllers there are. Yeah. Yeah, I haven't documented that yet, that's fine. The maximum number of controllers which can be connected simultaneously. Learn to spell. So it might be, say, 4. That's pretty common for a game, right? I think that'd be the same default. We can always go and change it if they need it. Oh, and get rid of all this as well. What's this extraneous stuff doing in here? It's not right, is it? Okay, so we've got the state of a controller, and I think this got quite complicated in the spec, because you can have a controller, here we go, we can have controller disconnected, or you can have all of these different kinds of controllers, but there's going to be a lot more than that, I think, eventually. And then in the upper bits, we've got all of the inputs, so... Man, there's actually a lot of bits, so we're hardly using any of them. Okay, so the 8 least significant bits specify the type of controller, as well as whether it is connected. So we're going to have the lowest 8 bits. A bit mask for the... it's going to be type mask, isn't it? Yep. For extracting the type of a controller from its state. This type indicates, oops, no controller is connected. This type indicates that a Xbox labeled controller is connected. Nice and simple. Oops, should probably actually type Xbox in there, that'd be a good idea. So I'm never quite sure on this, how you capitalize Xbox. I mean, does the B get capitalized? It feels like it should do, but I don't think it does. Okay, that's sort of sorted out. Next up, we've got the buttons. So add a mask for those as well. Okay, so this is going to be 6535. We'll divide, subtract 255. So that is 0, and that rolls over to 8, that rolls over to 4, and then that rolls over to 2. Let me just check that. Let me just check that in the calculator. You guys won't be able to see this. Yep, that's right. Good. Oh, maybe I should change this from type to labeling. Yeah, because the only thing we really care about here is like, it's there so you can put the right sort of, letters and stuff on the screen if you're like showing contextual help and stuff like that. Okay. So what we got? Yeah, the PlayStation ones are easier for me to remember. One of the things is you use like a lot of Xbox and Switch controllers, and I'm always mixing up where A, B, X, and Y are on them because they're so confusing. Despite the fact that PlayStation should be way more confusing, it's like arbitrary symbols. The fact that nobody else has used those symbols makes them easy to remember. Except cross, I guess. I guess that's common. For the north face button. So yeah, so I'm basically going to have these kind of like, I'm going to say that it's the north, east, south, west face button because what it actually is can vary so much. I was just thinking about like different controllers, like you'd actually expect the kind of like say confirm button stuff to be in different places, but you could just check the labeling and just change which button you're expecting. This doesn't yet support keyboards. That's something that's going to be later on, I think. No, not triangle. What am I doing? And yeah, I've gone northeast, southwest in here. That was something that must have been in the back of my mind when I was originally scoping all that. Okay, and then next ones we got are left trigger, right trigger. I'm just going to rename these actually. I've just changed my mind now. And once we've kind of got all these buffers sorted there, and you know it's actually building at that point, I've taken the web runtime from the game and very stripping a big chunk of it out and turning it into something that can talk to this newer engine. Okay, we've got that. Oh yeah, I've got one more. The options sort of like menu button. So we're just going to call that pause. Just because like it's basically what it is, right? So the button's far away from everything else. You can't possibly press it by accident. Okay, that's good. The other thing we need is the X and Y coordinates of the sticks. So I think I already got names for those in the buffer file, haven't I? Yeah, there they are. Did I write in the pointer file? Oh, there we go. What do they call these? What do they call these? Control the x-axis and y-axis. And we do a similar thing before, like we're going to say, see the controller stage for details. Okay, that should be good. Oh yeah, I actually need to put these into a little file to actually allocate the memory for them. Because at the moment we said that the memory is being allocated somewhere, but we haven't said where. And now we have. Yeah, I could have put all these in the same header file. I kind of like having them sort of separated out like this. It's kind of nice. Okay, are those going to pull in? Probably have if I, actually brought in the header for them, and the same for the pointer. That might now build, maybe? Or I could generate the document. Sorry, I could generate the documentation instead. That works too. Oops. And just do a nice little sort. I love the fact you can do that kind of thing with Studio Code. Just grab some text, press F1, they sort lines ascending. So nice. And just make sure it shows up here. Yep, there it is. And yep, that's good. Completely incomprehensible. It's what we want from our documentation. Okay, let's try building it. Okay, one thing left to sort out. Unexpected type name pointer state. Oh, hang on. Do we have a possible ambiguity here? Because we have both a... Yeah, we've got a pointer state type and variable. I guess we don't need the type if there's only one of them. We can get away without that. That'll probably do, right? And I should make a C file for this, if I'm going to be using it. Okay, that should be good. Go on, build. Not quite, not quite. I'm still using the wrong variable names. Damn it. Okay, that made us a binary. That's good. It's a binary. It won't do much yet, but it's a binary. Let's just commit all of that, given we just got that apparently working. Okay, next up we have to bring up this horrific HTML file, and this is basically the runtime. This is basically the bit that actually scoops up the module and runs it. At the moment, it's very complicated. Doesn't really need to be. I think we can cut most of this out. So where are we going to go? This numeric constant thing can just go. That's not super useful. Neither is that. Don't need that anymore. Because what this was doing for a while was I had all these functions, like these dozens and dozens and dozens. Oh wait, I still do need those actually. I had all these dozens and dozens of functions just returning like things like the screen size, the tick rate, things like that. And now they're all just in a memory buffer, so I don't need to do that. Yeah, I'm just going to cut all of this out, I think. Like all of it. And then feed it back in bit by bit. Yeah, let's get rid of all of this. We can feed it all back in later on. Get rid of that, don't need that. The advanced function can go, no, I'm not using that. all of this cursor stuff, all this advanced stuff, take all that away. It's all stuff to kind of like support that really complex render loop I had, where it was kind of like both tied to the visual and audio tick rate. And it didn't really work. It wasn't very well thought out. Don't need the canvas anymore. We're going to be putting that back in later. For now, we're just trying to get the buffers out and see what's in there and make sure it all makes sense to us. We've probably still got a try up here. Yep, there it is. Get rid of that. Okay. All right. I see the complication here, what I did before, so I can put those into there. Yeah, the complication I had here before was I needed to be able to, because I had this mechanism where I could get the last sort of error code out of the module. So I had to be able to call a function on it. But then I also had this initialization code that kind of ran between creating the module and actually using it. So I had like multiple nested try catches. It was getting quite horrendous. No longer needed though. We can now do that. And then a lot of these are probably no longer used. Probably. So let's back out of here and let's go to the runtimes. Sorry, hosting runtimes, go to our web one. Now at the moment, this I build script in here that takes this HTML and takes your module and kind of packages them together. And this is fine, except it's kind of built to really heavily optimize, like way beyond the point at which you'd actually want to run if you were, let's say, developing with it. So you got things like here where it's actually using Zopfli, or I'm not quite sure how you say it, to really, really crush those, like all the icons and stuff down. We don't need to do that as this isn't actually going on the website just yet. Should be able to run host. I run the host, not the build. Why did I do that? Oh, NPN. Working with transistors here, not not the node package manager. Okay, so this will, yeah, that has done a build. So now we can run the host. It should. Oh, I'm in the wrong folder. I was like, what? Oh, and then this terminal just froze up for some reason. Very good. Let's try that again. There we go. Now it's hosting. So now we should be able to launch into that. And it will crash. That's actually kind of expected. Let's have a look and see what we got. Oh, half it's off the screen for me. Oops. What do we got? It lacks a state buffers export. Yep, that's probably true because we've renamed it. It's now whatever it's called. I've forgotten. Yeah, it's just called buffers. Okay, so let's go to here. Buffer count. Let's just reorder these to match. Yeah, buffer pointers. Buffer sizes. And buffer identifiers. So one of the things is, one thing I'm not quite sure about actually is what the kind of correct type for a pointer is on the web, on the kind of hosting side, because I think WebAssembly is always 32-bit. I mean, like, I think it is. I might be wrong on that though. And let's make this a signed array because there's everywhere else. Let's make this a signed thing. Okay, that should be good. is not state. All these checks still apply. Should be good. Okay. Let's do another build. And we can then have it output to this and then put it on the screen so we can see exactly what it's kind of collected. It should give us a nice list of all of the buffers. Okay, it did. It gave us a nice little, let me zoom this in a bit. It's given us a list of basically, here's the identifier of the buffer and here's the data inside it. So this one here, this one, 60, that's probably our frame rate, right? Probably. And we've got like the 64. Don't know, but like we've got things here like the screen resolution. I can definitely see like 180. This is probably a screen. No, this one's probably our screen because this one's massive. This one's probably our audio buffer. So that looks like it's working. I mean, it kind of makes sense what it's doing. Most of these are all 0 because they're outputs and we're not rendering it, or they're inputs and we're not using them. So next up, we need to actually compare these against the ranges we've defined in the documentation. So yeah, if they're in this range, we need to declare them as state. So let's do that here. I don't think you can do like ranged switch case in JavaScript. I don't know if you can. No, you can't. That's fine. So let's have a look here. If the range is greater than or equal to 0 and it's less than or equal to this, then it's state, and that's good. Otherwise, if it's in this range, it's optional IO. Actually, I might just put a switch case in for that. That'd be good. That'd be a good idea. So this is what we've done here for required by the game. We're not going to implement any of those yet because we don't have any that we're currently using. Okay, what we're doing here, we have the identifier. Actually, can you like just put a switch on the end of an else like that? Oh, neat! I've never done that before. I didn't know you could. Put the identifier in here. Buffer identifier is required by the WASM module, but is not supported by this hosting runtime. Do you have any references to the word game in here? Yeah, let's be because one of the things I found was actually really confusing is I referred to the WASM module as the game, but of course to most people the game would be the module packaged up with its runtime. They're kind of like, they form the game and they're put together. So that's why I've started renaming it into kind of like WASM module and hosting runtime and calling neither of them the game. All right, there we go. So then we come to here and should be able to go all of these and link them to something useful. Okay. At this point, we need to check the size, make sure it's correct. If the one does not, do they have to define what happens if the size is wrong? Yeah, the hosting runtimes act as though buffers of an unexpected size do not exist. Is that useful though always? I'm not so sure it is. Okay, I'm thinking about changing this. I'm going to change it so that that only applies to state. For all other types, it's going to be like if the size is wrong, blow up. That'll be hella confusing as a sort of like a developer like building their own kind of like module for this. If the size is incorrect or inconsistent with other that of other buffers or inconsistent. I think inconsistent is probably a good term for it. You know, like say like if you say got the width and height and then the actual size of the buffer is wrong. Oh, actually, I guess you remove like the some of these because they're kind of implicit. I'm just going to paste this down here and paste this down here. Okay, so I'm actually going to remove on these buffers. I'm going to remove the, let me just turn off the wrap because it's giving me a headache. I'm going to remove the width for the video buffer. And the reason I'm going to do that is you can actually calculate it from the size of the buffer itself. Yeah. Happy about that. Removing features, that's what we like. And then I'm actually just going to shuffle these down just to make them stick together a bit nicer. And then I'm just going to go make the corresponding changes to the code base as well. Have I got rid of more than one of these? Anyway. Paste these into here. I think you write something and it seems completely rational at the time, then you think about it and go, no, that's wrong. Oh, I could probably put more in here, like this must be at least one. It's kind of validation you just don't think about when you're writing a spec and then you're actually going to use it and go, oh, that's wrong, that's wrong, that's wrong. So we no longer need the width for the video buffer, wherever that is. Video, maximum video columns, there we go. And go bye-bye. Obviously, once people are actually using something like this, you can't make changes like this. So it makes sense to clean them up now while you still can. Okay, that looks good, I think. So now we want to we want to take the memory buffer location size. Let's check it. If the size is 4, then extract the ticks per second. Otherwise, from the error. Size, ticks per second, size incorrect, expected for actual, actual, and then we're going to put our actual size in there. I'm just going to check in that design change actually. Where is it? It's the protocol. Yeah, let's just commit all that because that's all reasonable changes, nice and self-contained. Oh, you know what else we don't need to export? We don't need to export the samples per tick over because you can just calculate that from the length of the audio buffer. I got rid of that as well. Are we therefore using anything from there? No, we're not. We can get rid of that. Damn it, and I've just made all those numbers match up. And then we're going to make the same change in the protocol. There's a trick I could do here actually to say shuffle these all down by 1. Let's see if I can do this. Hang on, be the other way, be the other down. Can I do that? And then, hey, how about that? That was a nice little hack, wasn't it? There we go. It's ridiculous some of the stuff we can do with Visual Studio Code. Okay, that's good. That's good. Yeah, might yet find other things we can remove for the same sort of metric. So, okay, that's good. Then we're going to extract the first one. There's probably a better way of doing that, but that'll be fine. We're only doing that once at startup. And you can tell I've been writing Swift recently because I'm forgetting to write brackets around everything. God damn it. and then we can break out of there. These are now wrong because I've changed the spec. And we're not currently using the ticks per second, so... Oh, wait, this shouldn't be in here, it should be out here. I'm meant to be kind of storing it and then using it later. Let's print these out as well. I don't think JavaScript has kind of like a name of thing. C# has this really nice thing where you can basically, you can take any kind of like declaration, you can go like name of and then the thing, like that, and it'll actually generate a string reading the thing, and then if you rename the real variable, it'll rename with it. Very nice, but I don't think there's an equivalent in JavaScript. I should probably also be building the module. I don't have a terminal into the module. Can I move this into its own? Can I unsplit this? Oh, I can, nice. So I can resplit this into something more useful, such as building on one side and the WebAssembly module on the other. Given both ends are changed. Okay, we've got 60 ticks per second there, that's good. And we just next up need to continue working down the protocols. So let's put in here must be at least one. Okay. I did once try like a plugin for Visual Studio Code that made it automatically reformat these tables. Unfortunately, it was extremely buggy. It did all sorts of weird and wonderful stuff. Okay, video audio output buffer there. Okay, I think we're all good for now. I think that's the only one I really miss. So next one is audio output buffer, so we can get that out as well. And that's at the next slot, so oh, we can probably put a thing in here to say the size must be greater than 0 as well. I can't think of a good reason you'd ever have it be 0. Right, okay, so we're going to here. If it's a multiple of 4, that means it's correctly sized. And we can then set the audio output buffer. And we want a flip 32 array into memory at location, and we're going to use the size. Now I think that's the number of floats, so we want to divide that by 4. Ah, this is nice, this is nice. And it helpfully turns this let back into a const because it couldn't see any uses of it. That's fine, we'll turn it back. Okay, we can next get the height of the video buffer. And later on, we'll basically take all these kind of things that we have and haven't acquired, cross-check them, and then, you know, like say, go, oh, this has video, or this has audio, or this has controllers, or whatever, and kind of move them from there. Let's name that consistently. Okay, next up we have the height of the safe area. Okay. Safe area rows, safe area columns. It's going to start getting repetitive. Maybe we'll start seeing a pattern we're going to want to repeat. Oh, I just realised I've actually not updated this. Oops. Oh, that's sorted now. And I might actually start adding a list down here of things that need cross-comparing. To do ensure that video buffer size divisible by height. To do ensure that safe area height fits within video buffer. I think next up is the columns of the safe area. Yep, okay. And just compare. Yeah, it's definitely still 8. Okay, got it. Right, this part is incredibly dull. However, it should mean we have a nice kind of like fully set up set of data we can start running from. Okay, next up we have the pointing device state. That should be quite easy to do. Awkwardly, this needs to be an array of one item, which is a bit strange, but it's a good way of just representing it to the rest of the runtime. What was it called? Pointer state? Yeah, I did. And it is at 30. There we go. We're almost out of time. This has gone pretty weirdly quick on my end. I don't know if it's gone quickly for everyone else, but it's gone quickly for me. Okay, so we've got that, and next up we have the position, so that's the pointer rows, pointer columns. And however far we get with this, I'm just basically going to print it at the end and see what we got, see if what we got makes any sense. Did I assign the wrong thing here? Yes, I did. That's meant to be the audio. That's meant to be the video buffer, and I typed audio buffer. Next up, we've got the pointer row, pointer column. Next up, we've got the persistence flag. What did I call that? I called it persist. Fair enough. It's easy to remember. So this is basically kind of like a flag that's used to communicate back whether or not the hosting runtime should persist any kind of like game state. So sort of like a quick save or something. And then run to 34, which is tick progress. Yes, especially whenever the hosting runtime wants to render the screen, this is how it tells the game how far it is through the current frame. You know, kind of like gameplay tick. So, you know, if it was like at the start of the current tick, it'd be 0, at the end it'd be 1. What else are we have in here? Height of the... Oh, okay, right. The actual height and width for the video buffer. Do I have those in here? Doesn't look like I do. Oh, wait, that's the maximum video rows. Okay, right. Okay, I made a mistake. I named this incorrectly. It should be maximum video rows. And then we're going to have a video rows and a video columns. And this is basically going to be how the engine tells the game how big the screen is it's drawing to. Where is it? Where is it? Where's it gone? There you go. Next question. Did I ever default these in the protocol? It should be defaulted so that they fill the screen by default. I can't read this split. Must default to the height of the video buffer. The wrestling module should default this to the height of the video buffer so that hosting runtimes which ignore it get the receive the full buffer dimensions. That's simple enough. Now I've got to fix this table because doing that broke it completely. I wish I'd do that automatically. Time for a little bit more ASCII trickery, I think. Let's find and replace the spaces into hyphens, given I missed them. Oh, it's a spell checker really going to give me grief over the word runtime. Really? Fair enough, I guess. Okay, that's good, I think. Right, okay, we're coming to the end, so I'm just going to print all these out and see what we got, see what we've won. That's weird. Why did it deselect off the text off if we're using it? That's weird. Okay, so now we need to do a build, I think. Nope, build's good. And then build the runtime, and this should... After thinking about it for a bit. Okay, what's it giving us? We've got 60 per second. We've got an audio buffer full of zeros, that's right. We've got the maximum video rows, safe area rows, columns. We have video buffer full zeros, 0.6000. I'm also going to put into the protocol. Yeah, I should probably start putting defaults in here. I thought that'd be a good idea, just to kind of really, make it so it's resilient. So if the runtime doesn't support something, it's not the end of the world. So fill this in while it's fresh in my mind. Okay, that's good. It's good. Okay, that's good. That's good. It's good. Just sort all these little messes I've made here. I wish there was an easy way of doing this. I really do. Okay, we've got all that. Next up, I just need to make sure all these defaults, and I've actually, put them in the spec. I need to make sure that I'm actually using them. So let's generate the documentation again. It's still going. Oh, I know what this is. This is something that's a bit wrong with my configuration, where it's parsing every single file in the web server as if it's documentable, and I couldn't find an obvious way to stop it doing this. Oh god, it's still going. Oh god, this is so many files. Stop. Stop the web server. Delete the node modules. I'll think about it for a few seconds. It's a lot of files. Come on. Go. Faster. Go. How's it taking this long? Wait, I don't have something like, say, locking that file open, do I? I don't think I do. I've definitely stopped the web server, and there's nothing else that should be touching it. 1 second. Why is this taking so long? That's weird. That was way faster through Windows Explorer. That's almost never true. Windows Explorer is almost always the slowest way to delete files. Okay, now... Yeah, there we go. Search for default, and that's 0, that's fine. And so our tick progress should be 1. That's just so that if the hosting runtime doesn't support that feature, we'll always be displaying the most recent information. And we have the video content. Okay, that's going to be maximum rows. Again, that's just so that if the hosting runtime doesn't know what these are, it means that, worst case scenario, we just render the whole viewport. It's probably what you want anyway. And then we go to the audio listener and we default it to being at 000, and then looking straight ahead. And the reason for that is it's just so we get something rational out of it, even if the runtime doesn't pass rational information down. So it should be good. That should be good. Okay. Next up, let's do our build. Let's run that. And let's have a quick look at the data that came out and make sure it's sort of rational. Oh yeah, I kind of uninstalled everything, didn't I? Oops. At least it's nice and quick. It's all coming straight out of cache. Whoa, that's a lot of changes. Oh, hang on. I had a git ignore in there, and it's been deleted with the it's been deleted with everything else. How am I going to get that back? Because there's a lot of files in there. Look how many files are in there. It's ridiculous. It's probably at the bottom of the list as well. Yep, there it is. Bring it back. Okay, now we can build. Think about it for a bit. And we're also just going to rerun the web server. Said we're going to rerun the web, so there we go. Okay, what do we have here? Let's just make sure everything makes sense. 0, that's good. Video rows and columns is good. Safe area is good. Oh, looks good. All right, so I guess we can pick this up next time and just finish pulling these through, do some extra validation, and we should be good to go. Thank you very much for watching, and we'll pick this up tomorrow night. Well, not tomorrow night. It's a weekend, so it'll be tomorrow at 9 AM. Have a great evening.